problem number 1582 F1, that is Codeforces round 750 Div2 F1. And this is the problem statement. Okay, moving on to the solution. Uh, we are given an array of n integers, and we need to find all the possible values of x such that there exist k indices. Let's call them s1 to sk, such that the XOR of all these indices in the array, that gives us the value x. Now, a key observation in this question is, first of all, all the AIs are limited to the value 500. This is observation number one. Now, if we are able to find whenever we see any constraint on AI, that is AI less than 500, one thing that does strike us is that since n is of the order 5, 10 power 5, this is of the order a, then the overall complexity can be order of n times maximum of AI, or probably order of 10 power 5 times 500, something like that, something of the sort. Now, uh, another thing we can see is that if all the AIs are less than 500, XOR of all the maximum XOR possible can be uh, 1 XOR, 2 XOR up to 256. This is the maximum XOR, which is equal to 511. So the maximum XOR, so the XOR of any subsequence would always be less than 512. This is another observation. Okay, now we have these two observations. If you are able to answer the query, if does there exist a subsequence ending at I with XOR is equal to x, let's call this fix. If you are able to answer this query in order of 1, then we can see that there exists a straightforward solution uh, with complexity order of n times 500, which is given by uh, this pseudocode. Now, the only thing left is to find this function of ix, f of ix, in order of 1. How do we do that? Because fix is defined as, does there exist a subsequence ending at I with XOR is equal to x? Uh, not only a subsequence, an increasing subsequence ending at I with XOR is equal to x. Now the challenge with this is, how do we solve this is in order 1, because we need the subsequence to be increasing. So we'll have either one option is to iterate on all the indices j less than I, but then f of ix won't be order of 1, it will be order of n. So the overall complexity would be order of n square times 500, which is not allowed. So now what we do is that uh, let's store let's construct this array. Let's call this mini of x, which stores a minimum element for which XOR of a subsequence ending at the particular element we are considering, that is x. uh, we see that this can be maintained while iterating through I, because uh, okay, so because if we have a loop, like for if we have this loop, let's write it again. If we have for I is equal to 0, I less than n, I plus plus, for j is equal to 0, j is less than 512, j plus plus, if f of ix, if this is 1, that is if there exists a subsequence ending at I with XOR x, then mini of x is nothing but the minimum of mini of x and a of I. Yeah. So yeah, right. And initialize, this is the pseudocode. Initialize all the many of x values to be infinity, and to count the answer for every, we observe that for every x that is possible, that can be possibly obtained from this operation. For every such x, many of x would be less than infinity. For every x that is not reachable, many of x would be infinity. So to check the answer, finally check which all many of, which all for which all x many of x is less than infinity, and report those answers. Now moving on to the code. The code is very simple, as we discussed. Taking all the inputs, maintaining, if this the uh, if there exists a subarray subsequence ending at the index I with XOR x, if such a subsequence exists, then we'll update the value of many of x. Um, right. And first of all, we initialized all the many of x values to be infinity. Let's put it here. Then updating many of x. Then let's move on to f of x. The function is pretty straightforward. If uh, you can have a look, you'll understand. This is a very straightforward function. If we are at the first index, we return 0. If we are at if x is equal to 0, we there obviously uh, exists the null subsequence. If ai itself is x, there exists the subsequence of length 1. If this is the first index, then we return 0, because because neither of these two conditions were met. If the And we have to remember that we have to um, consider ai, since we are considering increasing subsequence ending at I for sure, so we need to consider ai in the subsequence. So the if we are considering the ith index in the subsequence, the XOR value left is XOR ai. If such a XOR value exists from the array in the array 0 to I minus 1, then we'll and if the minimum index and if the current element is greater than that minimum index, then we say that yeah, there exists a increasing subsequence ending at I with XOR x, else it is 0. um, and finally we report the answer. Yep.